Hi there, I'm Graham Lewis, and in this video we're going to look at odd and even functions, we're going to look at the symmetry, do some examples and prove algebraically whether a function is odd, even or neither. So here we have y equals x squared I've drawn, and you can see that this is symmetrical in the y-axis. And that's it, that's what an even function is. So an even function is symmetrical in the y-axis. Now, the reason they used the word even originally is that x squared, x to the power 4, x to the power 6, are all symmetrical in the y-axis, and hence the word even. So an even function is symmetrical in the y-axis. Now, when you consider an odd function, they came about by thinking about x cubed, x to the power 5, x to the power 7, hence the word odd. But we'll show in a minute that there are other functions that are odd or even that don't follow that pattern. And also there are some quadratics that are not even functions, and we'll discuss that as well. So let's have a look at an odd function. And here's an odd function, and you can see this has symmetry as well. It has rotational symmetry of order 2 about the origin. That means if I turn it around 180 degrees about the origin, it fits onto itself, and then I turn it around another 180 degrees, I get back to the start. So an odd function has rotational symmetry of order 2 about the origin. I'll just write that down for you. Notice it also has another kind of symmetry which is the same. You could reflect it in the x-axis and then the y-axis and it looks the same. Or you could reflect it in the y-axis then the x-axis and it will look the same. So I'll write that down for you. So there I've written it down. An odd function has rotational symmetry of order 2 about the origin, or think about it as reflect it in x, then y, and you're back to the original function. Or of course you could reflect in y and then x and you're back to the original. Okay, now let's have a look at what that actually means, this rotational symmetry. Let's consider the point -2 here. When I put -2 into the function, I obviously get -8 out as a value. And when I put 2 in, I obviously get the value of +8 out. Oops, sorry there. So you can see that it's the same absolute value but changes sign. So what we can see that f of -2 is similar to f of 2, but a difference in a sign, because f of -2 is -8, f of 2 is 8, so we can see that f of -2 is the negative of f of 2, because -8 equals -1 times 8. So that's our result there for an odd function. The f of a negative value is the same as negative of f of the positive value. So we can generalize that. Imagine now I did this generally and I called this point A or X, doesn't matter. I'm going to call it X, but you could call it A. I know a lot of teachers like to call it A instead. So now we generalize for an odd function, f of -x has to equal the negative of f of x. And you can see that when I work to get that rotational symmetry. Or you reflecting y, it's the same as reflecting x. In actual fact, if you think about this in terms of transformations, that's very helpful thinking about it this way. Because of course, f of -x is a reflection and -f of x is a reflection. This of course is a reflection in the y-axis, and this of course is a reflection in the x-axis. So interestingly, we're saying that if you reflect the original function in the y-axis, it's the same as reflecting the original function in the x-axis. Can you see that? And let's show that on fx graph. And here you can see a nice example of that. If I reflect x cubed in the y-axis, I get the graph that's shown -x cubed. And if I reflect it in the x-axis, I also get the same equation -x cubed, and there's the algebra there. So you can see that you can think of an odd function as if you reflect it in x, reflect it in y, it's the same. And that's where that algebraic expression comes from, that f of -x equals -f of x. If that is true, it must be an odd function because it's got that special symmetry. Okay, let's have a look at an even function. Okay, so if we go back to the easiest one, y equals x squared, because it's symmetrical in the y-axis, we can see if we put -3 in here, we get a value of 9 out. Equally, if we put 3 in, we get the same value, 9 out, because it's symmetrical in the y-axis. So we can see that f of -3 is equal to f of 3. If we generalize that and imagine any point, let's call it -x and x, we can see clearly that f of -x is equal to f of x. And that gives us that symmetry. So let's look algebraically what we've got so far about odd and even. So in summary, if we look at an even function and we think of that symmetry in the y-axis, when we explore f of minus x, it's got to be minus f of x. Of course, I've got this the wrong way around. I do apologise. Well done for those people that spotted that. So f of minus x equals f of x. If we look at an odd function, clearly to get that special symmetry, f of minus x equals minus f of x. This is wonderful because clearly we can explore f of minus x. If we explore f of minus x, one of three things can happen. If it's the same as f of x, we know it's an even function. If it's the same as minus f of x, we know it's an odd function. And of course, most functions do not have this special symmetry. So if it's not equal to those, then we know it's neither even nor odd. And that's how we can prove algebraically. So let's get stuck into a few examples that are interesting. So here we have f of x equals x squared plus x. We want to know if it's odd, even, or neither, and we're going to do it algebraically. So let's explore f of minus x. So you just put f of minus x into this function. So instead of an x, let's write in a minus x. So minus x all squared plus minus x. Let's use our algebra. A negative all squared is a positive, so that's the same as x squared, and a positive times a negative is a negative. So I end up with x squared minus x. It's clearly not the same as f of x, because f of x is x squared plus x. So we know it's not even, because it's not the same as f of x. Let's have a look at f of minus x, minus f of x, just to check. So minus f of x is minus x squared plus x, which is minus x squared minus x. So it's not equal to f of x, so it's not even. It's not equal to minus f of x, because that's here. So it's not even, and it's not odd. So this is neither. This is an example that's neither even or not. Odd. So that's a good example. I really like this example because it shows that just because this is an even degree polynomial, it is an even degree polynomial. It's a quadratic, of course, even degree. It's not an even function. And let's have a look at the picture of this on a fx graph, and we'll see that really clearly. And you can clearly see here, here's the graph of x squared plus x. It's not symmetrical about the y-axis, which of course we know not all quadratics, which are even degree polynomials, are not symmetrical about the y-axis. So not all even degree polynomials are even functions, only a very few are. Let's have a look at another example. Okay, let's have a look at x cubed minus x. So again, we explore f of minus x. So we'll pop that badger into the equation. So minus x cubed minus minus x. Do our fantastic algebra skills. A negative cubed is still a negative times a negative is positive. And Bob's your uncle. Maybe some of you can see straight away that is the same as minus f of x. Or if you want to, you can factor out the minus there, and then it will be really clear that this here is f of x. So we've got minus f of x, and we can write hence it's an odd function. So this function here is an odd function, and it has that rotational symmetry of order 2 around the origin, and you can sketch that if you want. Okay, a couple more for you to think about. What about these two? What about f of x equals 2 to the absolute value of x? What's that one? What about this one? What about g of x equals sine x plus x cubed? And even cosine x as well. Is that an even function, an odd function, or neither? Have a think. Hope you enjoyed this video. If you did, subscribe to my channel and watch some other videos. Thank you very much. Have a wonderful day, everyone.